Hi guys, my name is Mátyás and we are here in my backyard in Hungary to talk about some genuine Cold War Eastern Bloc goodness. This is the Polish DP-75 Geiger counter. First of all, I would like to thank my friend Christian for supplying me this device. It's been manufactured in 1985, but as you can see, it's in pristine, brand new condition basically. And it's working perfectly. So what we are going to do today in this video is briefly talk about the history of it, do a general overview, and then sort of a deep dive along with some field testing hopefully. So let's get to it. So the DP-75 was designed in the 70s in Poland by the Wojskowy Instytut Chemii I Radiometrii, which roughly translates to the Military Institute for Chemistry and Radiometry. And sorry for the pronunciation, I apologize to my Polish brothers. And it was used by the military throughout the 90s, and they are being calibrated even well into the 2000s, if I'm not mistaken. In fact, I've contacted the subsidiary of Polon Alpha, who does the calibration for DP-75s in Poland, and they were happy to calibrate this very device for me if I wanted to. Probably because it's reliable and sturdy, we will find out. One of the most interesting features of the DP-75 is its insane measuring range. It goes from 0.5 milliröntgens per hour to 500 röntgens per hour. So if the air tastes like metal, you can definitely measure it with this thing. It has 7 measurement ranges, as you can see here. We're going to talk about it a bit later. And it has an alarm system included with it as well. So it doesn't have a speaker, it does not provide audio feedback, but rather a continuous beep for the alarm threshold that the user have set. Another cool bit about the DP-75 is that it has not one but 2 Geiger tubes included in its probe, DOI-30 and the DOI-80, one of which is energy compensated, if I'm correct. Another important feature is that the DP-75 has the ability to charge a DKP-50 dosimeter right here. It's worth to know that they have made a lot of these things. And I have seen heaps of DP-75s in military depots and pictures, and that is how they made it to civilian hands, basically. And that is how I got mine. So, the crate itself weighs 7.5 kilograms, it has reinforced metal corners. Let's open it up and see what's inside. First of all, let's take the Geiger counter itself out. And here we have the rest of the case. We have a metal extension arm here, which I can just take out. It's held in place by this rubber strap and a metal hook. The extension arm consists of 2 pieces held together by this metal chain, and you can screw it together. Like so. Behind this sliding door that I can just take off is the cable for AC power. Here we have the opening tool for the battery compartment. We have a brand new spare carrying strap. Of course, we have a bunch of plastic bags for the probe to avoid contamination. And we have the papers for the DP-75. Let's take out the papers so we can see what's behind them. Here we have a rubber pad for holding the pack together when you're closing the case. Here we have a schematic of the contents of the box. And here we have an inspection sheet. You can see the inspection stamp, the signature of the inspector, and the date of inspection, which is interesting because the date says originally 27 September 1983, but it's been corrected with a pen to 1985. This red booklet here is the user manual for the DP-75. It has some really useful information. First off, we have a table for the measurement ranges of the DP-75 here. You can see that we have 7 measurement ranges going from 0.05 milliroentgens per hour to 500 roentgens per hour. Here we have some useful information about the GM tubes inside the probe of the DP-75. As you can see, it has 2 GM tubes, the DOI-30 and the DOI-80. The 30 is used across all ranges, from range 1 through 7, and the DOI-80 is used for the lower ranges 4 through 7. By the way, the DOI-80 is energy compensated. Towards the end, we have a neatly folded schematic for the DP-75 for maintenance and general overview. This is the calibration booklet for the Geiger counter. We can see the serial number, which matches up nicely with the one on the case, and the year of production, which is faintly visible, it's 1985. If we open it up, we can see the same data once again, and a couple of inspection stamps, signatures, and if we go to the middle here, we have the calibration data for the DP-75. We can see, I believe this is the error margin measured, and it's been calibrated for all of its 7 measurement ranges, and the company responsible for the calibration is Polish Alpha. And I contacted them. And funny enough, they have a subsidiary in Hungary who would be happy to calibrate this device for me today if I wanted to, which is pretty neat, considering this is a 40-year-old device. Here we have the last date of calibration, which is 1997, which is 28 years ago as of today. So let's talk about the DP-75 itself. It comes in a very sturdy leather carrying case with a nice window on it, so you can see your measurements even when the device is in its case. On the left side we have the earphone socket, 2 hoops for the carrying straps, so you can alternate based on which way do you want to carry this thing, slung from your shoulder or hanging from your neck, and we have the battery compartment. On the other side we have the cable of the probe, AC socket, and a leather flap holding the actual probe itself. In this small compartment we have the earphone for the DP-75. It's a Tonsil SM73, I think it's a Soviet-made earphone. And of course we have the compartment for the GM probe. To remove the device from its carrying case, first you have to get the GM probe out. It consists of 2 parts held together by a bayonet lock, so you can apply pressure, turn it, and you have a nice sturdy GM probe. The second step of taking the DP-75 out of its case is opening the battery compartment, for which I'm gonna need this tool. It's under considerable spring pressure, as you can see. And now I can just take the batteries out. The DP-75 uses 3 D-cell batteries, which is really nice because most Geiger counters of the era use various proprietary batteries, which are really hard to replace, and D batteries are really convenient, easy to use, and of course, as you can see, I'm using rechargeables as well. The last step is finding this threaded knob inside the probe compartment, reach in with one hand and thread it out. After that, you can reach into the battery compartment with your fingers and lift the meter out of its carrying case. So this is the DP-75 out of its carrying case. As you can see, it's considerably smaller than the case itself. So the meter itself has this brown, I believe it's a Bakelite casing, which feels very sturdy and very rigid. I believe it's Bakelite. It may be some other kind of resin material, but nevertheless it's a classic Eastern Bloc look and feel. Let's reinstall the batteries. All three D-cell batteries. And now we have the DP-75 ready to use. The probe itself is machined out of a nice, thick, high-quality metal. It has a rubberized handle with a clip on it, so you can wear it on your belt. At the end, it has these spring protectors along with the counter itself, which are protecting a cable that is a really heavy-duty, nice, thick, rubberized cable. The probe itself has two GM tubes inside, the DOI-30 and the DOI-80, and the DOI-80 is energy compensated. You can also open up the probe itself to reveal a beta window, as it is indicated on the end here. O stands for open, while Z stands for close. And you can indeed just screw the end off. It is also under spring pressure. It pops open, revealing the beta window inside. I can screw it out a bit more so it doesn't go back. You can see the GM tubes inside, and as you can see, it's a pretty small beta window. There's a mark here indicating which way the beta window is facing, which will come in handy later. The features of the probe do not end here, because you can also attach the extension arm, for which you need to take off the handle. Grab the extension arm and attach it the same way by these bayonet lugs. There we go. And you can gently reach for the cable, put it in these grooves and attach it here like so. And now you have a full search configuration probe set up for the DP-75. Currently, I have it so the beta window is facing downwards, which means I can search in this configuration, search for contamination on the ground, for example. But if I set it up the other way around, so the beta window is facing up, I can search the underside of cars, for example. As you can see, this mark is rather useful because I can set up the probe in an upwards or downwards configuration even without opening the beta window. So let's go through the controls of the device, starting with the right side. At the top here we have a zeroing knob for the DKP-50 personal dosimeter, which looks like this. This is a Hungarian-made unit, but all of them look the same. Here we have the reset button for the gauge, and below that we have a threaded cap for the slot of the DKP-50 dosimeter itself. At the left we have two combined selector switches and the illumination button for the gauge. The bottom selector here is the power switch and the range selector, and the top one here deals with battery check, gauge check and the alarm settings. To turn on the device, all you have to do is flip the range selector to the highest setting, 500 röntgens per hour. And since we are in battery check mode, we can see that the gauge is within the red range marked with a K. That means we have sufficient power. If we go to KP, we can check the gauge. It's working fully. We can test the reset button. And if we go to the infinity symbol here, which means no alarm, then we can start measuring radiation with the device. Of course, the reading on the gauge is 0 at the moment because we have the highest range selected, 500 röntgens per hour, And since we are not in the reactor 4 of the Chernobyl power plant, we can just go on down to the lowest setting, which is standard procedure, by the way, for Geiger counters. This is how you avoid burning out your GM tubes inside the probe. And now we are picking up background. So to be able to test the capabilities of the DP-75, do some comparisons with the Radiacode, or simply learn how to read its gauge, we need something of a check source. So for a check source, I have brought in Igor. Igor is a nice piece of uraninite or pitch blende I have found in Przybram, and he is a real potent piece of rock. So as some sort of a non-scientific reference tool, I have brought in the Radiacode, so we can get some basic values, basic dose rates and comparisons with the DP-75. And we can see that even with the plastic protective case or silicone protective case on the Radiacode, we are measuring well above 300 microsieverts per hour on Igor. I have done a long gamma spectrum on this specimen to get an accurate dose rate, and it turned out to be over 400 microsieverts per hour. Reading the gauge of the DP-75 is rather easy. The way it works is that the number you select here on the range selector will simply represent the end of the gauge here. So right now, for example, I have 5 milliröntgens per hour selected as my range. The gauge is showing between 3 and 4, which means I'm measuring about 3.5 milliröntgens per hour at the moment. If I bump it up to 50, the gauge will go back down, because now the end of the gauge simply represents 50 milliröntgens per hour. The only difference is with the highest scale, 500 röntgens per hour, because in that case you have to read the bottom scale. Let's talk a bit about the alarm feature of the DP-75. The DP-75 doesn't have an external speaker because instead it uses earphones, like this Tonsil SM73. In my opinion, the earphone is the weakest part of the DP-75 because it is not loud at all. It is barely audible and it is kind of wonky ergonomically. It barely fits onto your ear. But it works. So who am I to judge? It's 40 years old. The alarm system is pretty simple. Users can select up to 5 alarm levels from 5 to 1, and that simply means that when the gauge reaches a threshold that you have set up here, you will get an audiovisual warning, because the gauge will light up and the meter will send a signal to the earphones. Let's test it out. So I have plugged the earphone in, and what I will do now is turn the lights off so we can not only hear but see the alarm as well. So right now I have the alarm set at 5, which should be here, but I'm only measuring about 2 milliröntgens per hour. So either I move Igor closer or I have to set the alarm at a lower level, such as 1 or 2. Let's try it at 2 and maybe push the specimen a bit closer. And I have triggered the alarm. You can see that the gauge is now lit up and you can hear the alarm from the earphone. If I move Igor back, then the light will go out and the alarm goes off. If I move the specimen closer, the alarm is triggered once again. So I guess that this alarm feature is really good for field use, because when you're outside looking for contamination on the field, you don't want to look at the gauge constantly to see if you found something, but this way you can just hear the beep and you know that you crossed your preset threshold. So a cool feature of the DP-75 is that it also has a fluorescent gauge. I'm not sure if you can see that. It is weakly fluorescent. It goes dim pretty quickly, but if you're outside and it's sunny, it lasts you for about an hour. Of course, this is for a device that's 40 years old. If it does go completely dim, you can always just press the illumination button and it will do the job for you. Right now, I rearranged the table a bit to allow for some testing, and what I'm curious about is basically a small comparison between the Radiacode 103 and the DP-75. How I plan to achieve this is that I have set up my test specimen, Igor, a piece of uraninite from Przybram, in the middle, and I have set up the Radiacode and the DP-75's probe at roughly an equal distance from the specimen. I have also switched the measurement units of my Radiacode to milliröntgens to allow for easier comparison. Even though here in the EU we prefer microsieverts and the conversion is pretty easy, I decided to switch it to milliröntgens so we can read the values a lot easier. So let's get to it. On the DP-75 I am reading just above 2 milliröntgens per hour, and on the Radiacode I'm also reading just above 2 milliröntgens per hour, about 2.5, both here and here. So I'm pretty astonished because the two devices are remarkably close to each other. Of course, this is just a fun measurement and not a super scientific one, and there's a couple of reasons why. The first reason is simply that Igor doesn't present a uniform radiation field. I believe this side of Igor is a lot stronger and this side is a bit weaker. The second reason is that Igor also doesn't have a uniform shape, so it's not a sphere or a cube, which makes it a lot harder to measure stuff. The third reason is that the concentration of radioactive elements inside the mineral itself is also probably different and not uniform. The fourth reason is that the Radiacode can be sensitive to strong beta radiation because it can go through this plastic while it cannot go through this thick metal. And there's probably a lot more reasons, feel free to list them in the comments, but this is all I could think of at this moment. So basically, my results on both devices are essentially the same, which is amazing in my opinion, because the DP-75 is a 40-year-old device and the Radiacode is basically brand new. I bought it a couple months ago. So it's amazing how well the DP-75 stands up even after all these years. And not to mention, last calibration of the DP-75 was in '97, so 28 years ago as of today. So right now I have moved the two detectors further apart from my specimen to see if anything changes. And on DP-75 I'm measuring just above 1 milliröntgen, and on the Radiacode I'm also measuring just above 1 milliröntgen per hour. So the two measurements are basically dead on to each other. I'm also amazed because I have read a lot about other Geiger counters of the era, and sometimes they have error margins of 30 or 40%. With that kind of error margin, you can only just ballpark the exact amount. But here we can see a lot more accurate measurements. I think the DP-75 owes its relative accuracy to having not one but two GM tubes inside this probe. There's 40 years setting the two devices apart. I cannot stress this enough. I don't know, it's maybe just me, but I'm super excited about this. It's amazing, really, just amazing. So let's open up the beta window. So the beta window is open. I'm at the 5 milliröntgens per hour scale, and now I'm gonna grab Igor and see how far this thing can go. So I'm almost sure that it's gonna instantly peg out. Yeah. Reset. And I will go to 50. Let's see. 50 is gonna peg out as well. So 50 milliröntgens per hour equals 500 microsieverts per hour, by the way. Let's go to the big leagues. I'm at the Röntgen scale now, so I'm measuring between 0.1 and 0.5 Röntgens per hour. Let's see. Climbing, climbing, climbing. So right now I'm measuring just above 0.1 Röntgen per hour, which is really funny. Of course, this is not an accurate measurement by any means, but 0.1 Röntgen per hour translates to 1 millisievert per hour, which is really funny. To compare this, let's close the beta window. Put Igor on the same spot. So right now, I'm measuring Igor at point-blank range with the beta window closed. Here, I'm at the 50 milliröntgens per hour level, and the gauge is showing 2, which equals 20 milliröntgens per hour, or 200 microsieverts per hour, and that is energy compensated gamma only, which is pretty amazing for such a small specimen. So I've set up the DP-75 into its search configuration. The beta window is open. It's facing the ground, so if I'm sweeping the ground like this, it will face the ground. And I have the alarm set to the lowest possible setting, so I've set it at 1, and the measurement range is 0.5 milliroentgens per hour. So let's see if I can find Igor down there from this distance, which I highly doubt, by the way. I can definitely hear the alarm, but only if I'm hovering above Igor. But still, this is really a good indicator of the sensitivity. I'm at a good 40 centimeters above the specimen, and the specimen is in a plastic case. So yeah, I'm hovering at about 0.2 milliroentgens right now. So it's pretty crazy, actually. I can barely hear the alarm, but I guess they made it this configuration so I can, you know, detect the sounds of the environment, perhaps a nuclear war around me much easier. This way my ear is free, my other ear can easily detect the very faint sound of the alarm. But if I want to make this harder, if I just sweep over it like this, it's definitely not picking up enough radiation to detect Igor. And that is because this window is super small. So I believe that's a shortcoming of the DP-75, that the window is kind of small here. But if I just put it here, I'm already hearing the alarm. So I'm really surprised. And the alarm again. And the alarm is on. That's how long it took. So I have to be directly above the mineral in order to detect it, but still that's impressive. And now I can hear the alarm. So that took what, 3 or 4 seconds. So I would definitely not go mineral hunting with this one, but it's impressive nevertheless. And the alarm is on. So it has decent sensitivity for its age. Yeah. So I'm gonna do another test. Igor is set down there on the ground. My beta window is open and my alarm is set to the lowest possible level. So I will see if I can measure Igor from here. And now the alarm is on. I'm checking if I'm picking up anything from this far, but not really. But if I'm getting closer, and the alarm is on. So I will do a kind of a sweeping motion here. And the alarm is on. So right from the get-go, it's on. I'm gonna open this up so I can reset it. Let's see how fast it sounds the alarm. It's on. Let's make it more difficult. I'm putting it up to the 5 milliroentgens per hour scale, and I'm still at the first alarm level. So I should get a warning at 1 milliroentgens per hour. Yeah, so far nothing. So as I figured, the alarm should only work on the lowest. And now I'm getting the alarm. So it took quite a lot of time. But if I reset the meter and go to the lowest setting, here is how fast the DP-75's alarm is. And it's on. In fact, it's constantly on. Let's see if I get something with the beta window closed. I'm curious. I'm gonna say no. Reset and test. Actually, it took quite a lot of time, but the alarm still works. I was also curious about some real-life response times from the DP-75. So I hit some radioactive rocks in my backyard, as you usually do, and tested how long does it take to trigger the alarm on both the DP and the Radiacode. In hindsight, I should have set the alarm on the Radiacode to 0.05 mRNGs per hour to match the one on the DP, but you'll see that it does not really matter given the Radiacode's response times. It's worth to note the obvious that I'm comparing a scintillator to a GM counter, two completely different techs. And of course there's the 40-year difference as well. However, this is the only other device with an alarm system that I own, so I thought it would be interesting to see what happens. We are getting to the end of the video here, but I don't want to go into a strict verdict. The DP is a very well built machine, and for Cold War standards it is a very fine instrument in my opinion. Its relative sensitivity astonished me even today. I really hope you like this kind of content. If you do, please subscribe. Thanks for watching and see you in the next one.